Have you ever wondered how the entire modern web actually talks to itself? I mean, from the newest startups to giants like Google and Amazon, there's a common language being spoken. Well, today we're going to pull back the curtain on that language, REST architecture. This is the blueprint behind so many of the APIs we use every single day. Let's get right into it. So here's our game plan. First, we'll tackle why you should even care about REST in the first place. Then, we'll build everything up from its absolute foundation, the resource model. From there, we'll cover the core rules or constraints, dive into some really practical design tips, and talk about what it takes to make a system truly production-ready. And to wrap it all up, we'll look at a cool way you can actually grade any API's maturity. All right, first things first. Why does REST matter so much? Look, this isn't just another technical acronym to memorize for an interview. It's the architectural style that has pretty much dominated how we build for the web for over 20 years. If you're a backend engineer, understanding REST is absolutely fundamental.
And that begs a really important question, right? In an industry where new tech comes and goes every year, how has REST stayed on top for so long? What gives it that incredible staying power?
Well, the answer is actually pretty simple. REST isn't some super strict protocol or a rigid library. It's an architectural style. Think of it more like a set of guiding principles or a blueprint. And it's a blueprint for building systems that are simple to understand, easy to scale, and just plain friendly for other developers to use.
Okay, so to really understand REST, we have to start where REST itself begins, and that's with the concept of a resource. Literally everything else we're going to talk about today is built on top of this one single powerful idea.
So what is a resource? Easy. It's a noun. It's a thing in your system. A user is a resource. An order is a resource. A product is a resource. It's never an action, like get user or create order. The most important mental shift you can make is to start thinking about your system in terms of these things, these nouns. So how do we find these things? Well, every single resource gets its own unique address. We call this a URI, a Uniform Resource Identifier. This is so key. A URI gives us a consistent, predictable way to point to something. For example, /users might be the address for the whole collection of users, while /users101 points to that one specific user. It creates this logical, almost folder-like structure that's super intuitive. Now, here's a crucial distinction. The client, like your web browser or mobile app, never gets direct access to the resource sitting in the server's database. I mean, that would be a total mess and super insecure. Instead, the server sends back a representation of that resource. You can think of it as a snapshot of its current state, usually in a simple, readable format like JSON. Okay, so if our resources are the nouns, how do we do things to them? We use the verbs that are already built into the HTTP protocol. We use get to read, post to create, put to replace the whole thing, and so on. See the beauty of this? The address, the URI, stays the same, but the verb we use completely changes the action. This separation is at the heart of REST's elegance. Now hold on. Just because you're using nouns and verbs doesn't automatically make your API RESTful. To really earn that title, a system has to play by a specific set of rules, or constraints. And honestly, these constraints are where REST gets all its power. Here are the big ones. Client-server separation is huge. It lets your UI and your data storage evolve independently. And then there's statelessness. This one is a total game changer. It means every single request from a client has to contain all the info the server needs to do its job. The server basically has amnesia after every request. Why? Because it makes scaling the system out horizontally way, way easier. Now, among all these rules, there is one that stands head and shoulders above the rest. Roy Fielding, the guy who literally invented REST, pointed to the uniform interface as the absolute central feature. This is the secret sauce that makes all REST APIs feel consistent and predictable. The uniform interface itself breaks down into 4 smaller rules. We've actually already covered the first 2, using URIs to identify resources and using representations like JSON to manipulate them. The third is self-descriptive messages, which just means a request should contain everything needed to understand it, like a content type header saying, hey, this is JSON. And the fourth, hey TOS, is this really powerful idea that the API's response should actually give you links for what you can do next. So an order response might literally include a link to cancel or track that specific order. The API guides you. All right, enough theory, let's get our hands dirty. How does all this translate into designing clean, effective APIs in the real world, the kind of APIs that other developers actually enjoy using? This right here is probably the #1 mistake I see people make. Your URIs identify nouns, period. The action lives in the HTTP method. So it is always get/users and never a URI called /getUsers. Just getting this one convention right will make your API instantly more readable and predictable. Okay, beyond just naming, there are a few other things every real-world API needs. You absolutely need a way to filter and sort data. You need pagination, because you can't just dump a million records on your client at once. You need a versioning strategy, like putting /v1 in the URL so you can make changes without breaking everybody's apps. And you must have rate limiting to protect your service from getting hammered. And then there's this other crucial concept called idempotency. Now, this word, idempotency, sounds fancy, but the idea is actually super simple. It just means you can run an operation multiple times and it will have the same effect as running it just once. Think about it. Get, put, and delete are all naturally like this. Deleting something twice is the same as deleting it once. But post is the odd one out. If you post to /users twice, you've just created two different users. Understanding this difference is absolutely critical for building reliable systems that can handle network errors and retries gracefully. So you've designed a beautiful, clean API. That's awesome. But that's just the beginning. To survive in the real world, under real traffic, that API needs to be a fortress. It needs to be secure, reliable, and you need to be able to see what it's doing. This slide really drives the point home. A production system is so much more than just a few API endpoints. It's a whole ecosystem. You've got to think about security, about performance, about reliability. All these things have to work together to keep your service healthy, fast, and safe. And the key is to think about these things from day one. Authentication is just answering the question, who are you? Authorization answers, okay, now that I know who you are, what are you allowed to do? To make it fast, you need performance with things like caching. To keep it from falling over, you need reliability patterns like retries and circuit breakers. To know what the heck is going on inside, you need observability with logs and metrics, and of course, to handle more users, you need scalability. This stuff is what separates a weekend project from a true production-grade system. So, finally, how can we actually measure how RESTful an API really is? It turns out there's a really handy model for this, and it's perfect for analyzing systems or even just talking about them in an interview. It's called the Richardson Maturity Model. Level 0 is basically just chaos, using HTTP as a dumb pipe. Level 1 is when you start introducing the idea of resources. Level 2 is where most good professional APIs live today. They use resources and HTTP verbs correctly. And then you have Level 3, the true pinnacle of REST, which fully embraces HTOAS, where the API itself guides the client. Striving for Level 3 is the ideal, even if Level 2 is where most of us operate. And that brings us to a final thought for you to take away. Think about the last API you built, or even just one you've worked with recently. Using this model, how would you grade it? Is it a Level 1, a solid Level 2, or does it actually achieve that Level 3 ideal? It's a fantastic way to apply these concepts and really solidify your understanding. Thanks so much for watching.